this will be our last section of projectile motion, and this sort of ties everything together where we can use our equations to find a lot of different things. So we're still using the same equation, the equation h of t equals h sub 0 plus v sub 0 t minus 16t squared. It gives the height in feet of an object t seconds after it is launched into the air. In this equation, that h sub 0 is your initial height, that v sub 0 is your initial velocity. So we've seen that over and over again. So what we're going to do here is we are going to have this situation. A rock is thrown from a bridge that is 32 feet tall. It takes the rock 1.9 seconds to hit the ground. What is the initial upward velocity of the rock? So these problems are going to be ones that we have to do a little bit more work than we've been doing for the others. Desmos has pretty much done everything we needed for the other problems. But for these problems, we do know initial upward velocity. So we could write this equation, h of t equals, we do not know initial upward velocity. We know initial height is 32. And then so we will add to that. I do not know what v sub 0 is right now, so I'm just going to have to leave it as v sub 0, and then we have minus 16. I'm sorry, this is not writing well. (16t squared). And so in this case, we do have this information. We know how long it takes the rock to hit the ground. So if we think about this, when the rock hits the ground, its height is going to be 0. Not its initial height, but its height is going to be 0. And then that time when that happens is going to be 1.9. So we can take these values and plug them into our equation. So right here, the height is going to go over here for this h. So we'll have 0 equals 32 plus v sub 0, because we don't know it, that's what we're looking for, times 1.9 minus 16 times 1.9 squared. And so I want to solve this equation right here for that v sub 0. That's what I've got to get by itself. The first thing I'm going to do is I've got this 16 times 1.9 squared, and I would just like to know what that is. So 16 times 1.9 squared is 57.76. So that is going to give me, I'm going to have 0 equals 32 plus, I'm going to write it this way, 1.9 times v sub 0, because we usually just write that variable last, and then minus 57.76. And so what I can do now is I'm trying to get that v sub 0 by itself. So I could take that 57.76 and I could add it over here to the other side. And so I will get 57.76 is going to equal 32 plus 1.9 times v sub 0. There's some other ways you could solve it. You can move the 32 first. You could combine the 32 and the 57. So don't get too caught up on that. The next thing that you want to do is you need to get that 32 over to the other side. So I'm going to subtract that 32. Subtracting 32 from both sides there. So if I take this value right here and I subtract 32, I'm going to get 25.76. Equals 1.9 times v sub 0. And then the last thing I'm going to do is divide by 1.9. And so if I do that 25.76 divided by 1.9, I'm going to get 13.558. So 13.558 0.558. And velocity is measured in these cases in feet per second. So my initial upward velocity, my v sub 0, what I'm looking for here, is 13.558 in this case. And that would be the answer for this problem. All right, let's try another one of these. Okay, so same situation with the equation. A kickball is kicked from the ground. It takes the ball 2.7 seconds to hit the ground. What is the initial upward velocity of the ball? Round your answer to 3 decimal places if necessary. So, in this case, we are creating that equation, and we don't have a number for the initial upward velocity, but we do know the ball is kicked from the ground. So that tells me that my equation will look like this. H of t equals 0 plus v sub 0 t minus 16 t squared. And so I know that it takes 2.7 seconds for the ball to hit the ground. So for my height, when the ball hits the ground, the height is 0, so I'm plugging in 0 here. And then for that t, I'm going to plug in that 2.7. Okay. And so I'm going to go over here to Desmos real quick and just see what 16 times 2.7 squared is, and that is 116.64. So I'm going to have 0 equals, there's no real need to write this as 0 right here. And then so I'm going to write this as 2.7 times v sub 0, just because we normally write that number first instead of the variable. And then the 16 times 2.7 squared, we just found it was 116.64. And then we just got a couple steps to finish solving that. We're going to add that 116.64 over here to the other side. And so that gives me 116.64 equals 2.7 times v sub 0. And now I'll divide both sides by 2.7. And if I go over here and do that, 116.64 divided by 2.7 is going to give me 43.2. So my initial upward velocity here is 43.2, and that is feet per second. Okay, here's our next situation, and this one's going to be just a little bit different because it asks us for a little bit more. So same equation, same general information that we've been seeing on all these problems here. A volleyball is hit into the air from an initial height of 9 feet. It takes the ball 0.8 seconds to hit the ground. What was the maximum height the ball reached? So notice here, this does not ask us for initial upward velocity. It asks us for the maximum height that the ball reached. However, the only information that we have right now to write our equation with is that initial height. So we would have h of t equals 9 plus v sub 0 t minus 16 t squared. And without having that initial upward velocity, we cannot write ourselves an equation that we can put into Desmos that we can find that maximum height with. So what we're going to have to do here is first we're going to have to find the initial upward velocity, and then we can use our equation to find the maximum height that the ball reached. So just like on the problems that we were doing, the ball is going to hit the ground at 0.8 seconds. So I'm going to plug in 0 for the height because the ball has hit the ground, its height is 0. And then I do not know initial upward velocity. I'm going to leave it alone. The time is 0.8. And I'm also going to plug in 0.8 here for that other time. And so this is our equation that we need to solve for v sub 0. So if we've got 16 times 0.8 squared, then we get 10.24. So we've got 0 equals 9 plus v sub 0. Actually, I like to write that 0.8 first. I think it just is more customary. And this is 10.24. So I'm going to add that 10.24 and add 10.24. And so that's going to give me 10.24 equals 9 plus 0.8 v sub 0. And I'm going to subtract the 9, which is going to give me 1.24 equals 0.8 v sub 0. And if I do 1.24 divided by 0.8, I'm going to get 1.55. So I'm dividing both sides here by 0.8. And that gives me 1.55 is my v sub 0. Okay, now the question didn't ask us for 1.55. The question asked us for maximum height. But now that we've found that initial upward velocity, we can write ourselves an equation. h of t equals 9 plus 1.55 t minus 16 t squared. Do not plug in the 0.8 for the t here, because if you do, then you won't have any variables in it when you graph it on Desmos. So if I type this equation into Desmos now, like we were doing on some of the other problems that asked for maximum height, I can look at Desmos here and I will see right there that, let's see, do I have this typed in right? Let's see, I'm going to have to zoom in a little bit. Oh yeah. This is probably not the best problem I've ever made, because if you zoom in right here, you can see right there, it was looking like it was 0.9, but it's actually this point right here. It's 9.038. So maximum height is 9.038 feet. So this volleyball was not hit up into the air very much. It was hit sort of straight out and down. Because its maximum height was not very high. So that is an example. Now the last example I want to do is I want to show you guys what you were going to do if you chose to do the catapult experiment. So last week, or at the beginning of this week, you had the option of either designing a catapult or you could actually build a catapult. So if you actually built the catapult, you're going to have two options for the assignment that goes with this problem. You can either complete the catapult experiment, which is really just going to be answering sort of one problem, or you can take the quiz and canvas that goes with this. So the quiz and canvas is going to have 7 problems, so it's a little bit more work. But for this, you are going to build your catapult and you're going to conduct the experiment as I'm going to show you here. So the first thing, let me show you real quick what it's going to look like if you pull it up here. Catapult experiment right here.
Strawberry for lunch.
So the catapult experiment looks like this. So you'll have these 5 questions that you have to answer. You can just write them on paper. You'll take a picture of them and send them to me, or you can type them in. Either one is fine, and send it to me. So you can do this if you would like, if you'd rather do this instead of the quiz in Canvas. And let's get rid of that. So let me go back over here where you can see what we're doing. So the first thing you're going to do is you're going to measure the initial height of your catapult. So if you've got some sort of catapult that looks maybe something like this here, and right here is where you sit your little tiny pumpkin or whatever it is you're throwing, your rock. And so what you want to do is you want to measure this height right here. The height from that little cup or whatever you have there that is where your pumpkin's thrown to the ground right here. So you want to measure that height. So I'm going to go with what my catapult was. So my catapult had a height of about 27 inches. Now, I do not want to put in 27 inches because everything in that equation, the h sub 0 plus v sub 0t minus 16t squared, is in feet. So what I'm going to have to do here is I'm going to have to take 27 inches and divide it by 12. And so that's going to be 2.25 feet. So if your initial height was only 7 inches, don't put 7 right there because it's going to be like it's 7 feet. But put 7 divided by 12 and use that decimal instead. Okay, so that's my initial height right there. The next thing I'm going to do is I'm going to actually launch the catapult. And I'm going to try my very best to measure the amount of time it takes for that projectile or the rock or the candy or whatever you're throwing to hit the ground. Now, this is a little difficult to do. You can use a stopwatch on your phone or something, but it's a little tough to get it just right. So I'm going to use what I have for mine, which is a rough estimate because it's not very close, and 1.34 seconds. Okay, so 1.34 seconds. So that's the time that it takes for my pumpkin to hit the ground or whatever it is I'm throwing. So I'm going to use this formula to find initial upward velocity of the catapult. So my initial height was 2.25. So I've got h of t equals 2.25. Plus, I do not know what v sub 0 is, so I can't plug it in right now. Okay, I do know that it took 1.34 seconds for this projectile to hit the ground. So I'm going to put 0 right here, and I'm going to do 2.25 plus v sub 0 times 1.34 minus 16 times 1.34 squared. And so I'm going to go over here and figure out what 16 times 1.34 squared is. And so that's going to give me 0 equals 2.25 plus, I like writing that 1.34 first, so 1.34 times v sub 0 minus 28.7296. And so I'm going to add that 28.7296 over here to the other side. that'll equal 2.25 plus 1.34 v sub 0. Sorry, that is a mess right there. And then I need to subtract the 2.25. And so if I take this value right here and I subtract 2.25, I'm going to get 26.4796. So 26.4796 equals 1.34 v sub 0. And then so our last step here is divide by 1.34. Sorry, this is really not writing well. And so if we take that number, the 26.4796, and divide it by 1.34, we get 19.76. I'm going to go ahead and round that off to a 1, 761. That's my initial upward velocity. So that answers the question that we were asked for number 3. Now, we're going to be asked a couple more questions. Next, it's going to ask to write an equation that gives the height of your projectile t seconds after it has been launched. That's just asking you to write the equation that you're going to plug into Desmos. So your h of t will equal 2.25. Oh, let me just type this. This is really writing terrible. Let me type this here. So h of t equals 2.25 plus 19.761 t minus 16t squared. So that is our equation that we're going to have for number 4. And then the very last thing it's going to ask us is to find the maximum height of the projectile. And since we've already got that equation, that's not that difficult to do. So we're just going to go to Desmos and type in our equation. So 2.25 plus 16 point, oh, I've forgotten what it was. It is 19.761. So 19.761 t minus 16t squared. And so I can see over here my maximum already. And if I point there, 8.352 is my maximum. So for my catapult, 8.352, 8.352 feet is the maximum height of my projectile. So that's about how high the rock was thrown, which seems fairly reasonable for mine. It didn't throw it incredibly high. So this is what you'll do if you're doing the catapult project. You'll just use your numbers. Or if you would rather, this is very similar to what you're doing if you take the quiz. You can take that quiz also if you would like.